So in this one, let's understand what caching is all about. So caching is a very popular way through which we can get performance out of our system. The idea is simple. We put the data, the frequently accessed data, in a place which is faster. That's the whole idea, right? Now caches are places where we store the data. So caching is a technique. Caches are the places where we store the data. Now cache as a place is anything which helps us avoid an expensive network IO, disk IO, or computation. So in any case, for any computer in the world, there are only three factors that we have: network, disk, and CPU, right? RAM is where we typically cache the data, right? So whatever helps us save an expensive network IO, or save an expensive disk IO, or save an expensive CPU computation is a cache for us. So some examples. Let's say we want to get a profile information of a particular user, right? Now for this, what we typically do is we make a call. The call comes to our API server talks to database joins 5 or 6 different tables to compute the profile information, and we send it back to the user. Now joining the 5 or 6 table is an expensive process, right? So what we do is, instead of going to database every time, once we have the profile information, we cache it in a cache. Let's say Redis is the most popular cache at the moment, but Redis, Memcache, pick your favorite and you store it there, right? So we are caching this information. So now next time when the request comes to our API server, we talk to Redis, get the information and send it back. No need to make those 5 or 6 joins when request comes to our database. We don't hit the database at all. We go to the cache, read the data, send it back to the user, right? Other example is when you would want to read a specific line from a particular file. We cache that information. Like, this is an expensive disk IO that we are doing. If it is, we are repetitively reading it. Why to make that call? Can we not just cache it in memory? Or when we are doing multiple table joins, as I gave you an example, right? These are the things that are expensive. So we are caching as part of performance improvement. We are caching those things in a cache. Now, in most cases, caches are a temporary storage location, which means that if that cache goes down, there is not much impact. There is a bit of performance impact in it, but if your cache goes down, your data would anyway be coming from the database. I'll give an example. So let's say your user made a call to your backend, right? User made a call to your backend. It came to our API server. API server, what it would do? It would first check the cache if it has the data or not. If cache has the data, good enough, we send it back to the user, right? So cache has everything which is frequently accessed and pre-computed, and it is very fast to access the cache, right? And if the data is not there, API server makes a call to the database, fires an expensive query, gets the response, puts it into the cache, gets the response and sends it back to the user. This way what happens is our cache is always updated, and because the data is not changing, that is another advantage that we get. That in case, let's say, in case your cache is down, what would happen? The worst that would happen is the request comes to our API server and cache is down, so API server can go to the database, fire that expensive query, get the response, send it back to the user. We were anyway doing it. So cache is like a supplement. It is just making things faster. It is helping us save an expensive IO operation, a lot of discretes, a lot of table joins, a lot of expensive computation that we were doing. It is just helping us save that. And that's what the job of the cache is all about, right? So this is where we are storing the data. Now, obviously, when we are storing something in a cache, it needs to be faster than the database, right? Like faster than what was expensive. In this case, a database query, right? So here, because it is faster than database, now what happens is things that are faster are typically more expensive, right? So which is where you cache the data that you are very likely to be requiring in next few minutes. Otherwise, you don't cache all. You say, hey, I'll just cache all the data. But the time you do that, your cache is typically storing data in memory. For example, if you take example of Redis, it stores data in memory. RAM is very costly. So if you store data in the RAM, you would need huge amount of RAM to store all the information there. It becomes very expensive. So that's why we never cache all the data that we have. Instead, we just cache a subset of data that is more likely to be accessed. I will ask, how do you know which data would we need more? Typically, this is where you see the pattern of your system, that hey, in my system something that is recently published is more likely to be accessed. So let me cache it. For example, tweets. When someone tweets on Twitter, that tweet is very likely to be sent to every one of their followers. Everyone is very likely to read that same tweet. Now, for a recently published tweet, it does not make sense for us to make calls to database every time. Instead, we can cache the recent tweets in a cache so that when request comes in to read the tweet, we go to the cache, read the tweet, send it back to the user. This is where it makes sense. This is where caches come in very handy. It helps us reduce the load on the database. It helps us save those expensive computation, right? So two very famous caches out there. First is Redis, second is Memcache. Redis is way more popular and way like superb database in general. Highly recommend you to check that out. In case you haven't worked it out, in the exercise I'll talk about what you should do, right? In order to understand caches better. Okay. Now one thing, it's a very popular understanding that hey, caches store data in RAM. To be honest, that's not completely true. Caches are not just restricted to be a RAM based storage. Redis stores it in RAM. It does not mean that all the caches will store data in RAM. The idea is simple. A cache is anything which helps you save an expensive network or disk computation. Simple, right? So now what you do is you store it in a place. So cache is anything that is quote unquote nearer so that you avoid an expensive computation. So when I say near, here in this case, because the time to access a cache is small as compared to going to database and read it, this is quote unquote near to us. So that becomes our cache. In some cases, even API server can become a cache. The disk of API server, the memory of API server can become a cache over here, right? So that we don't make an expensive call to database and get it, right? That's the key idea. So don't just limit yourself into thinking that cache are only RAM based. Cache is literally any storage that is nearer to you, that is closer to you, so that you avoid an expensive disk or network IO, right? That's all cache is all about. In general, cache typically have key value based access pattern that you put something in the cache with a specific key and you get it from the key, right? For example, if you're caching the profile information, your key could be profile ID. So when you are checking the cache, you check if this key exists. If it exists, give me the value and you send the response to the user. If not, you go to the database, get the profile information, cache it in the cache with that same key and you send it back the response, right? So they're simple hash tables, which is basically key value based access. It typically does not offer you any other functionalities. Obviously, no one's stopping from database from doing it, but in a very broad sense, you can think of caches as glorified hash tables, right? Okay, some examples of caching to conclude this is Google News. On Google News, you are very likely to access the most recently published news. How likely are you to access news which was published a week back? Not much, right? But the news which is very recently published, a lot of people are very likely to read that same news. So it would make sense for Google News to cache that particular recently published news article. Second, authentication token. Authentication token is being checked on every single request that comes to your backend. Now, if you make this call to your database every time, that puts unnecessary load onto your DB. So typically authentication token are cached in your cache and they're just checked for validity from there. This helps you reduce the load on your database. And now given that when a user is online, user is very likely to make calls to your backend system. So which means on every request you are trying to access that access token to see if it is valid or not. So why to put load on your database? You just cache it for some time so that you avoid the calls on your database. And on live stream, let's say you are streaming a cricket match, streaming a football match, the last 10 minutes of the data, the most recent 10 minutes of the data can be cached on CDN. We'll discuss CDN in depth in the coming videos, but we can cache it on the CDN so that whenever users are using or whenever users are watching it, users are very likely to see the most recent part. At max, they would go like 10 minutes back and say, hey, what's happening? Let me just take a look. Most of the people will have this behavior. So you're optimizing for most common behavior. This way, when you're streaming something live, most of things are being served from the cache itself. You don't have to go to your actual backend database to read the video file and send it back. This is where caches comes in. So when should you use cache? Wherever you see a need or wherever you see a pattern where you are seeing that a particular thing is accessed frequently, that's your place. That's your place to put a cache. Don't just add cache for the sake of it. It might not give you benefit. Places where you see that an item is very frequently accessed is where you know I can cache this information. Right? So to conclude, a small exercise is part of this. For you to understand caching better, what you should do is first, you should set up Redis locally. It's a simple binary that you need to run, but set it up locally. Second, put some data, get some data, play around with the basic commands that it has so that you have understanding of what gets stored, what gets retrieved, how you play with that. Third, you measure the time it takes. Maybe write a small Python script that makes a call to Redis, gets back, you measure the time that you get. And then do that same operation on a relational database that stores something and gets something from it. Try to measure the time between the two. You would see some very interesting behavior there, which I would not spoil it. Just play around with it to understand how caches work, how database work, what is the performance difference between the two, and you'll have very interesting time implementing it. So yeah, that's all what I wanted to cover in this one. Thank you so much for watching. I'll see you in the next one. Thanks a ton.